Hello again. In this lecture, we're going to examine how to generate a sequence of non-random values in NumPy. To be more precise, we'll use the arange function to generate an array of consecutive values. All right. So, the name arange is just short for array range, and this function is NumPy's equivalent of Python's range function. By default, it creates a sequence of consecutive integer values within a given range, and returns it as an output. The main difference between the two is that the range returns a range object, while array range outputs an array. Hence, if we type in range and pass it some value like 30, Python will return some range as an output. If we transform this output into a list, we see that it contains all the integers between 0 and 29. Therefore, we expect the array range function to produce a similar result. To see if that's the case, let's call np.arange. We've already imported the NumPy package earlier in our Python notebook, so we'll move straight to calling the function. We begin by defining a variable with an appropriate name and setting it equal to np.arange. The RNG here simply stands for range. Then, in the parentheses, we'll add a numeric value, like 30. As always, we want to check the output of the function, so we call the variable we just defined. Fantastic! We can see an array containing all the integers from 0 to 29, which is very similar to what we had earlier. The only difference being that we're now storing the results in an nd array. Notice that we have 30 values in the array, starting from 0 and ending before 30. That's because the function assumes we want a closed open interval. That means we're including the value at the start of the interval, but excluding the one at the end. So, even though the range goes from 0 to 30, we don't include 30 in the array. Right. If we have a quick look at the documentation of arange, we'll see that it takes up to 4 arguments: start, step, stop, and data type. The first 3 specify the range of values we're generating, with start and stop being the 2 endpoints, and step being the jump between values. This should all feel very familiar, since it works almost identical to indexing values. We say almost because there are a few oddities you need to keep in mind. To see for yourself, just paste the code into a new cell and set the stop argument equal to 30. This results in an error, meaning the function can't produce a sequence by only knowing the ending point. However, if we set the start argument to 30 instead, the function compiles. The output is identical to the one before because when a stop argument isn't provided, the function automatically assumes the ending point equals start and switches the origin to 0. Of course, if we specify both arguments appropriately, start to 0 and stop to 30, we also get the same result as before. Great! Next up, we'll specify the step between consecutive values in the array. This can be an integer, like 2 or 5, but it can also be a float, like 2.5. Let's see what happens if we set it equal to 2.5. We get an array of floats, starting at 0 and ending at 27.5, which are all exactly 2.5 apart as we go along the sequence. Lastly, we can specify the type of the values within the array. If we set it to a decimal one, like float 64, we'll see an identical array to the one we just saw, as all the values are still decimals. However, let's see what happens when we set the type to int 32. The output is slightly different from what we might have expected. Instead of just rounding the values from the previous array, we can see an array where all the values are exactly 2 apart. This is because the function works solely within the realm of integers, so the step becomes 2. Therefore, we start from 0 and take every even number until we reach 30. Right? Well, not exactly. There are exactly 12 original steps of 2.5 in the interval between 0 and 30. Even though our current step is 2, since we're only using integers, the function assumes we want the same number of elements and only returns the first 12 values within that range. Even though it makes little sense to use integers when we have a float step, it's important to understand how the function behaves in such conditions. The better we understand how array range works, the easier it is to deploy it successfully. Superb! Now that we've learned how to use NumPy to create arrays that store sequences of values, we're ready to move on to generating random data. In the next lecture, we'll define what a random generator is and how to use one. Thanks for watching.